In this video, the 16th in the Getting Started series, we will learn about configurations and learn some additional functionality such as adding aspects, parameters, appearance themes, and associativity. Fusion enables the creation of configurable designs, offering control over parameters and features through a table. This functionality is incredibly powerful for generating design variations without the need for individual remodeling. If continuing from the last manufacturing video, switch from the Manufacturing Workspace to the Design Workspace with the Spool design. Edit the first sketch in the timeline. To make things easier to understand in the configuration table, we are going to name some of the dimensions in the sketch. Double-click on the 37.5 diameter dimension and type in OD equals 37.5. Then, double-click on the 24 diameter dimension and type in ID equals 24. Then click on Finish Sketch. In the Configure menu, click on the Configure icon. This puts us into the configuration mode and brings up the configuration table. You will notice items in the timeline are highlighted blue. These are all the items that can be configured. In the configuration table, click on the Add Parameters or the FX button. This will bring up the parameters table where you can expand open the Sketch 1 under Spool. In the table, you will see the OD and ID parameters along with many other dimensions. Now you can see why we named them earlier. Click the checkboxes next to OD and ID in the parameters table and they will get added to the configuration table. Then, press OK in the Parameters table. Refer to Exhibit 1. Next, click on the Hole feature in the timeline. A hole configuration dialog will appear. Click on Suppression and Diameter in the dialog. This will allow us to either turn the holes on or off in the design or to change their diameter. Press OK and then click on the Pattern feature in the timeline and select the Quantity option and press OK. Notice how the table is being built out with all of the options we have selected. The hole diameter column can easily be renamed by right-clicking on the column and selecting Rename Column. Change the name to hole_diameter. We can also rename the configuration to Original by right-clicking on the configuration name and selecting Rename. Refer to Exhibit 2. To add another configuration, click the plus symbol. All information will be copied into the new configuration, and the blue bar next to Configuration 2 will indicate that it's active. Any changes made in the table will be reflected in the 3D model. In the table, change the OD to 38 and the ID to 20. Change the hole diameter to 4 and the hole quantity to 18. Notice how the 3D model updated with all of these changes automatically. Rename this configuration to Lite. We can toggle between the two configurations by double-clicking on their name in the configuration table. To configure different materials for appearance or mass properties, right-click on the top-level spool in the browser and select Configure. In the dialog that appears, click on Physical Material. A physical material theme will be added to the configuration table. rename Theme 1 to Aluminum, and then close the configuration table. Refer to Exhibit 3. From the Modify menu, select Physical Material, and in the search field, enter Steel. In the results, scroll down until you see Steel, then drag Steel onto the spool and close the Physical Material dialog. Bring the configuration table back up and click on the Aluminum pull-down, and notice Steel is now part of the list. Click the plus icon to add a physical material theme. Rename the theme to Steel and change the pull-down to Steel. Notice in the configuration table there is now a physical material column. Select the Steel theme for the original configuration and leave Aluminum for the Lite configuration. Then close the table. Refer to Exhibit 4. You can also select which configuration you want by choosing the configuration from the browser on the left. Currently, we're looking at the original configuration. If we do a mass properties of the top level, we can see that the material is steel and that the mass is 90 grams. If we change the configuration to light and do the mass properties again, this time it shows the material as aluminum and the mass is only 26 grams. Let's go ahead and save the spool. You will notice a warning appears saying that the spool will be saved as a configured design. Go ahead and press OK. Open the fishing reel assembly from the data panel. After opening, it will notify you that the spool is out of date. Click on the Update icon in the main menu. The spool in the browser is now called Original, as that was the name of the configuration, and it is displaying the original configuration in this fishing reel assembly. Right-click on Original in the browser and select Switch Configuration, and it allows you to select which configuration you want as part of the assembly. Select Light from the configuration dialog and press OK. Refer to Exhibit 5. You can also use configurations to show different design styles. For example, we want to show a left-handed and a right-handed style of this fishing reel assembly. Start by creating a new component called Handle Assembly and drag the Handle Start, Handle Grip, and Fastener into that assembly. Activate the top-level assembly and then right-click on the handle assembly and select Move Copy. Click on the Create Copy checkbox in the dialog, then move and rotate the copied assembly to the other side of the fishing reel and press OK. Refer to Exhibit 6. Turn off the first handle assembly. Using Rigid Group, group the handle and the end cap together. Then, use the Joint command to create a revolute joint between the handle and the reel. Now turn off the second handle assembly and turn on the first. Right-click on the first handle assembly and select Configure. Check the Visibility option and press OK. Then, right-click on the second handle assembly and select Configure, and check its visibility option on also. Start by renaming Configuration 1 to Right-Handed in the Configuration table. Next, add a new configuration using the plus icon and label it Left-Handed. For this left-handed setup, deactivate the first handle assembly and activate the second. Finally, close the configuration table. Refer to Exhibit 7. In the browser, make sure that the configuration is set to left-handed and then save the assembly. The warning message will appear again, notifying you that the assembly will be saved as a configured assembly. Switch back to the spool design by clicking on the Spool tab. We can see that the configuration is the Lite configuration that has the larger holes and hole quantity and smaller spool inner diameter. Change from the design to the Manufacturing Workspace. Our setup with all of our toolpaths are listed, but they are all out of date due to the changes made to the model. Right-click on Setup and choose Generate. All of the toolpaths will regenerate. The only change we need to make is to change the drill from a 3mm drill to a 4mm drill. Also, notice because we referenced the hole quantity parameter in the drill pattern, the drill pattern is now drilling 18 holes instead of 12. Refer to Exhibit 8. Lastly, open the fishing reel assembly drawing. Notice in the drawing browser, the top-level assembly is labeled right-handed, as that is what the first configuration in the configuration table is. Right-click on right-handed and select Switch Configuration, and it will allow you to change the current sheet to the left-handed configuration. Notice the view updates and even the parts table updates depending on what is visible in the view. Clicking on the second sheet in the drawing set shows the top, front, right, and isometric views of the whole assembly. Again, we can choose to have this sheet display the left-handed configuration and the views will update. Some of the existing dimensions get removed as they were associated with geometry that is no longer visible. So rerun the automatic dimension command to recreate the missing overall dimensions. And that brings us to the end of the Autodesk Fusion Getting Started series. Over the course of this journey, you've gone from the fundamentals, like creating fully constrained sketches, building and editing models, and working with a timeline, to tackling more advanced challenges. You designed a bail component, explored constraints and extrude to object, and even learned how to bring in external models, position them, and modify them with direct editing. From there, you leveled up with powerful tools like Sweep, Loft, and Form, giving you the ability to create complex organic shapes, like those in the fishing reel assembly. You assembled parts, inspected them for issues, and generated professional drawing sets, even tapping into Fusion's built-in AI features to speed things up. Then came the Manufacturing Workspace, where you added toolpaths, simulated machining, and saw how Fusion helps you validate your design before cutting your part. And finally, you unlocked the power of configurations, giving you the flexibility to explore design variations and make late-stage changes, knowing your drawings and toolpaths will update automatically. But this is just the beginning. There's a whole world of Fusion resources waiting for you, whether it's the self-paced learning right inside of Fusion, or the active community on YouTube, Instagram, Facebook, and more. I hope that this series has left you feeling confident, inspired, and ready to take your designs further than ever before. Now it's your turn. Go create, explore, and see what Fusion can do for you.